Okay, hello everyone. My name is Jeremy, and this presentation is going to be about the RoboCup Junior pre-college age rescue simulation entry level using the simulation environment Weebots. So what you'll learn in this workshop, we'll explore how to manipulate the simulation software called Weebots. We'll explore how to add objects into the simulation environment, such as robots, obstacles, and sensors as well. And I'll go through some samples and modify a sample map to show you guys what it's like. And then by tomorrow, we will have the sample code that I do here, as well as other samples posted to events.stormingrobots.com. I'll give more information on that later. And by the way, Weebots has a lot of very helpful tutorials. So after this presentation, you might still be a little uneasy on some of the topics. That's okay. So what I recommend you do is go to the Weebots tutorials and actually check them out. They're very long-winded. It's very in-depth and detailed. So here I'm going to try to go through it a little bit of a high-level depiction of it. So first thing you got to do to use Weebots is install it, and that comes from cyberbotics.com. If you just Google Weebots, download, this will show up. The current version, like the most up-to-date one, is 2023B. Just be careful. Whenever you see the installation date is like really, really new, you might not want to install it right away because sometimes there are some bugs. It is open source software, so it's free, which is nice, but sometimes there's some errors when they first release it. So right now, 2023B is the most recent and it's stable. So that's what we're using. All right. And then using the robotic simulation. So some things we're going to cover is a little bit of the terminology about the environment. So some of the terms and phrases we'll be using, such as world, scene tree is just a Weebots way of saying environment objects within the simulation. Then there's 3D view, a controller or your program. Then there's text editor, which is Weebots version of, programming environment. And then proto-nodes, which are special things that we can add into the scene tree, and they're just predefined objects. Okay, and again, here is more guides on how to get started with Weebots. So first things first, when you open up Weebots, not after you install it, but when you start working with it and you open it up, you're greeted with the world here. So this is just a general view of a world that I made. And over here, this is the scene tree. I'll be going into more details in a moment. And this right here is just a general 3D view. So you can see here, it's on a arena here. This is just like a floor with a wall, and there's a box added in. And this guy right down here is the robot. It's called the ePuck. Okay, so the scene tree. The scene tree can get a little bit complicated. This is what it looks like when you first start to open up and kind of dive down into the scene tree. But the scene tree has all of the information about what's in your world. It's just in a text format here, and it's got all these numbers and descriptions and settings that you can manipulate in order to change the environment to be, whatever you want. Note, so all of these things are referred to as nodes, and nodes are basically what you add into the scene tree in order to create, new objects, give them colors, give them shapes. You can create like physical boundaries for objects so that things can't just pass right through them. And all that is done through adding what are called nodes. Okay, so the 3D view is basically just the scene tree, but displayed so that, it's easier for us to navigate. Because, working through the scene tree to do everything and actually see what's happening is not very practical. So we have a 3D view here. And so the 3D view, this robot isn't moving or anything, but the 3D view gives you the ability to kind of look and get a better gauge as to what the sensors are seeing. These lines on here, by the way, are it's called optional rendering. And I'm optionally rendering the LiDAR sensor on the robot here. So you can get an idea of what the sensor is really looking at without having to, code it and test and just guess. And it does this for all the sensors. It can do this for cameras. It can do this for, in this case, a distance sensor, laser sensors, like anything you can, optionally render what it's viewing. And that's just the 3D view right here. Okay, now there's controllers, or in other words, it's programs. It's how you have the robot. It's how you program the robot and communicate with the environment, the world itself. And so as you can see over here, we've got the robot ePuck, and it has its very own controller like feature, I guess, property, that's the right word. It's got its own controller property. And when you double click on this and you select to, select a new controller, all these options will pop up based on the controllers that you've made. And this is a little bit of what it looks like on the side here. So yeah, controllers and text editor. So here it is. Here's a text editor. Now, this is what a bare bones program looks like when you first create a controller. Now, you can't just go in and create a .cpp file whenever you want and like throw it in a folder somewhere and then use that, because Weebots is very particular about the folder setup and everything like that. So I'll show you guys in a little bit, but if you go through the Weebots wizard, they call it, to help you set up all the files necessary, it's kind of just like a step-by-step process of selecting options and things like that. And then once you're done, it'll generate all the folders and files and everything for you. And one of the really important ones that it generates for you is called a make file. Now, a make file is just something that allows, or that Weebots makes for you so that you can just build the program. You don't have to go in and make one yourself. It does it for you, and then it just works right right away. So that's the text editor. Okay, proto-nodes. So here's the scene tree over here. And if there's this little plus button right above where the scene tree is, and that's how you add nodes. And proto-nodes are things that, they don't exactly exist in Weebots right away. These are things that we've made, or students here have made, and they worked really, really well. So what they did was they put it in a special file, and then everybody else can use it too. You just have to put it in the right place, and then you can, use basically you can use materials that other people have created in other Weebot simulations. So that's proto-nodes. They're rather nice. Okay, so next, guys, I just want to reiterate, this is just an overview of what I'm going to cover. I'm going to go into all of this much more in depth very soon. So the next thing I'll go into is adding objects into the simulation, such as obstacles, sensors, and cameras. So that's going to involve a lot of scene tree navigation. The scene tree it sounds simple, scene tree, but it's really a very, there's a lot of details there, and a lot of details that you need to know, and then some that you don't. So I'm going to go over how to navigate through that scene tree, so you're really looking for what you need and not just guessing randomly. And through scene tree navigation, we're going to add some objects and some sensors. And again, there's Weebots tutorials about all of this as well. So again, I'll cover this with an example later, but here's an example of an ePuck robot. Okay, and whenever you add sensors or LEDs or screens, even, or anything to your robot, it goes under this section called children. So these are basically like sub nodes that are a part of a larger node. And so inside this ePuck, inside the sub nodes or children, there's all these nodes that the ePucks just come with. ePucks come with Weebots. They're just a robot made by a company called GC Tronic. And it comes with all of this stuff already on it. So for organization purposes, I create a node called group, basically a folder, and then I can, add my stuff in there so it's separate. So this is the scene tree. This is what we'll be exploring later. And I'll go through it step by step and add a sensor so you can see what it's like. And adding objects is the same as adding proto-nodes, except after clicking the little plus here, you just go to base nodes instead. In base nodes, we can add stuff like solids. So you can add like an obstacle for something like RoboCup Jr. Line tracing. We can add obstacles that the robot has to navigate around while it's running. Okay. And adding sensors is, again, this button here. However, you just have to make sure you have the right thing selected in the scene tree. So again, it's just adding nodes, but you have to manipulate the scene tree, a special way. So we'll cover that. Now, overview is done. I'm going to do a little walkthrough here and show you step by step, all the things I've mentioned here. And if you want, you can contact office@stormingrobots.com to join our private Discord channel. If you ever have questions or anything, or you're working on something and it's not working, or you download sample code and it's not working for some reason, or you're confused about it, you can always ask here. Okay, so let's go ahead and open up this world. So this right here is the world that was in all the pictures as well. There's no code over here yet. So one thing I want to mention before we dive into this is that Weebots, like I said, it's very particular about what you do. So if you ever create anything new for Weebots, always make sure you do it through what they used to call their wizards. Basically, it takes you step by step through how to create a new project as wizard. So you can specify where you want it saved at. I'll just call this one test. Next, and then this would be like a new world that I want to add. So we'll just call this again test world. And this right here is a way where you can add, this automatic rectangle arena. So just follow through these steps, read carefully, and I can create a new project directory, and it adds all this stuff in there for me. So I don't have to set up any of it. Folders like worlds, that's specifically where all your worlds have to go. If they're not in that folder, it won't work. Same thing with controllers, same thing with protos. And then we have plugins and libraries. Plugins will not be covered today. That's for, more complex physics simulation stuff, but we will do stuff with worlds and controllers. And when you do that, actually, I don't want to do that because I want this to say here, but when you do that, it will automatically generate a Weebots directory for you. And it looks a little bit like this, except tiles, that was something I added. So here's the world we're running. It's called Box World, and it's a WBT file. It's a specific thing to Weebots. And so here we go. Now, navigating around once you have your world open is, simple mouse clicks. So you can rotate the camera by just doing a left click and then moving it left to right like this. And you can rotate around with the camera. You can also pan the camera left and right like this with a right click. So you just right click and drag. Now in the Weebots tutorials, they call this translation. So you can translate the camera, but it's also panning. You can pan the camera. So this is just left click, right click, and it does take a little bit getting used to. If you want to zoom in to get a closer look on your robot, you can just use the scroll wheel and scroll in there and zoom in and then zoom back out. Okay. Now, like I said before, the scene tree over here is everything in your world, all of it. Okay, so you can navigate to everything I'm about to click on through here, or you can first just click on the object itself and it'll highlight it. So this is an arena here that gets automatically generated, and it has all these protos that, again, Weebots just does for you, which is kind of nice. Then, if you wanted to, you could also click on like this box that I made. And this itself is just a solid. So group is just a way to organize things. That's all, nothing special. And then this right here is a solid with some other properties. And I'll make a solid later so you can see how it's done. But you can also get to the robot. You can get to your epoch just by clicking on it, and then it'll automatically highlight for you in the scene tree. So, okay. All right. So this is the epoch right here. And the epoch comes with a lot of stuff already added on it, but we're going to add something even more today. So this right here is a LiDAR. And again, it's doing some optional rendering. And that is found through View, Optional Rendering. And you can see there's all these other options for things that you can render, and you can get a view of what's going on in the simulation. Right now, I just have it on for LiDAR paths and point cloud. And this one only does paths at the moment. So, another thing that I forgot to mention that's rather important. So if you're moving around the camera and you accidentally like zoom in somewhere or mess something up and you can't really, fix it where you're at, there's this little button right here that'll take you back to your original view, and it'll just, be right back to where it was. Let's go ahead and explore the epoch here. So, when you get an epoch, when you get an epoch, the first thing that happens is, let me add one so I can show you. It's actually a proto itself. So I can go in here, proto nodes, Weebots, robots, find GCtronic, epoch, and there it is. So I can add it in. Now, when you first add it in, it's a proto, which, by the way, you can tell it's a proto by the purple here. They don't give you access to everything. You can't really modify this. It's meant to just be an out-of-the-box robot that you can actually physically buy. These are sold. But if you want to, make any changes and add your own components without building a robot from the ground up, you can actually convert it, from the root, from being a proto, you can convert it to the base nodes, it's called. And then I have all the other options like I had on this one. So you just have to convert root to base nodes, and you can, do whatever you want with it. So here's this epoch. Let me go ahead and save. And by the way, guys, when you're working in the scene tree here, it's really important the simulation isn't running. If you make changes while it's running, there's a potential for error. So make sure you always have it paused and set back to 0. So in here in my epoch, I can check out children. Now, again, it comes with a lot of stuff. So this is like the left motor right here. This is the right motor. And it comes with a bunch of distance sensors on it already. So those are definitely programmable, but we're going to go ahead and add, our own stuff. Actually, before we do that, let's just take a look. Never mind. I'll talk about that later. So, oops, it's already here. So in here, the children have already added a camera, which we use to simulate a light sensor, because Weebots doesn't actually offer any sort of light sensor or color sensor. So we just take a camera, point it down, and then grab a pixel from the center of it. We can determine the RGB values and whether or not it's over dark or light colors. And then there's a gyro on here and a LiDAR. And the LiDAR is the one showing the stuff here right now. Okay, so I want to add a sensor. So if I want to add a sensor to my robot and I want to add it here inside my group, I can click on the children and then I can click on the add button here. And so I have all these base nodes to pick from, tons of sensors. And the reason this is great is because you don't really have to, you don't have to pay for any of this. You don't have to wait for shipping. You don't have to worry about it breaking. You can just add sensors and explore as much as you want. So where is the inertial unit? So the inertial unit, IMU, it gives you yaw, pitch, and roll of the robot. So we can use it to potentially make really good 90-degree turns. So inertial unit here, and I just say add, okay? So it adds that on there. And the first thing you might want to do is name your sensor, especially if you're going to be adding multiple of them. You don't want it to just start duplicating names, and it always appends like a 1 or a 2, and it gets messy. So you should always name it. I'm just going to call it my IMU. Okay. Now, one thing about adding sensors is when you first add it, let me make sure I get this right. It's just invisible. There is nothing there. Well, the sensor will work. You can use it to get values, but it doesn't really look right. So I'm going to go through a quick example of how you can actually add like physical attributes to it, so it looks like a real sensor. And then, by the way, once you make this sensor, you can just copy and paste the node. So if you're doing line tracing and you want to have 5 light sensors, you don't have to do this 5 times. You can just copy and paste these nodes. But this is the process of doing it at least once. So I have my inertial unit, or IMU. It's called that, and I want to add children. So I can just double click on this, and it'll automatically be ready to add the base nodes. So I want to give this thing actual form. So I'm going to add in a solid. Okay, and you'll notice there's still nothing there. That's okay. So my solid object also has children. It has nodes that I can add to it. And so for this one, I want to give a shape to my solid. So a subnode of my solid is going to be shape, and shape has appearance and geometry. So this is where the thing is actually going to start to take form. So if I go in here in geometry, I want it to just be a box. Okay, so I can add a box. It's obviously not going to look like this when we're done. So let's change the size. So far we've gone through to the inertial unit and we've added a solid that also has a shape, and we made it a box, and we're going to make it much smaller now. And I just want to do this and say this now before I forget. And sometimes I forget. When you make changes to the scene tree, like big changes like this in terms of adding in nodes, and in this case, I added 3 full nodes. If you don't save it, okay, and you revert or reset the simulation with this button here, if you don't save it, it will just disappear. So just a warning, it's going to happen. It happens to everybody, where you build something and then you accidentally reset it and it disappears. So just make sure you're always saving and you're always starting at 0. So now that I have this on here, I can, I can also give it a different appearance. So appearance only has set, options. You can't do like anything you want. This appearance right here would be if you wanted to add like an image. You have a picture of the actual thing and you want to add that image as an appearance onto the shape. You can do that. this is more of just a simple version where you can add like different like textures and stuff to it. And I'm just going to make it a basic color here. So I'm going to add this, and then I'm going to change the color. I'm going to make it red. So you just type in 0.1, hit enter, and it'll change. And it's a little dark, so I'm going to increase this. All right, so now we've got our red IMU here. I'm going to lower it a little bit. And I don't know if you noticed before, but lowering it and moving it is just using these arrows here. And you can rotate it as well using the curve around here. So, oops. So we'll put the IMU on there. And then make sure I save. Okay, so now that it's saved, we can close some of these windows. So it's got an appearance, it's got a geometry. And now, oops, little disconnect there. Hold on. So what I did there was I accidentally moved the solid instead of the inertial unit. So I'm going to go ahead and just move the solid back up, and then I'll move the actual inertial unit down. That way they're not separated. So now they're both in the same spot. Okay, so the scene tree, a lot of this you don't have to worry about. It's children and then subnodes that you want to worry about. The subnodes are what actually give it, form, and name. Name is important too. So there you have it. We've added an inertial measurement unit, or an IMU, and now when you're coding it, the name is very important. So, okay, so let me just go to the other names as well, because there's another name that we're going to need. We're going to need the name of the motors in order to use the motors. So if you double click on here, all you got to do is go to device, and there you have it. There's a rotational motor as a device, and it's called left wheel motor. And for right wheel, it's the same thing. It's just right wheel motor. And we need that name because I'll get to it in 1 second. So now that I have my IMU mounted and I have my robot, I want it to start driving around and telling me, what orientation it's in. So if you guys were going to be programming this from scratch, you would do File, New, Robot Controller. Now, just like with the project directory and also with Worlds, it'll like basically take you through the process of creating it, and you'll have to, select some options and things like that. So in this case, for a robot controller, you have to select your language. Here I'm going to be using C++, but you can use whatever you're most comfortable with. And then IDE, so Weebots does work with Microsoft Visual Studio, but for now, I'm just going to use the Weebots own text editor over here. And then I'm just going to call it test controller. Okay, now, just like with the project directory, it'll basically run you through what it's doing. And so what it's doing is creating this folder here inside the controllers folder that's going to store not only the CPP, but also the make file. And yes, I want to open it when I'm done. So this looks like a lot, but it's not. It's actually a lot of comments. A lot of comments telling you, where you can write stuff and what you can write in there. But I'm going to go over what automatically gets generated here. So in this case, it's including robot, the robot class. And then also in C++, you have to say using namespace Weebots. Now, the robot class is actually how your code and the robot interact with the scene tree itself, okay? And the robot, the first thing it's going to do is actually get the time step from the world. And if I go in here to world info, I have a basic time step of 32. That's set in the environment. And that's by default 32. And the time step is, it's the increment used by Weebots to advance the virtual time and perform the actual physical simulation. So each time you advance that time step amount, in this case 32, the simulation will run that much. And to actually run the simulation itself, that's what this while loop is for. So everything before this while loop is just setup. And we'll see some of that in a moment when I set up motors and I set up the IMU. But everything prior to this while loop is set up. And then once you get to this while loop, that's when, rubber hits the road and the code actually starts generating responses in the simulation itself. So nothing's really happening yet, moving around here. The time is staying still until you hit this while loop. and then the time will start ticking and things will start happening. The robot will start moving, sensors will start getting data. So this while loop is really like your main. This is where you want to put all the code for your robot to do, is in here. So I'm going to go ahead and open up the sample right now. And one thing, it returns -1 when you exit the simulation or you reset the simulation. That's the only time it'll actually exit this while loop and then end the program. But if you play and then pause, if you play and pause, it'll just remain inside this loop, and you can press play again whenever you want or reset it. Okay, so let me go ahead and close this. Okay. So I'm going to be opening up this one right here, sample controller. Oops. Okay. Let me cover this for a second. So sample controller. Now, whenever you make a new controller, or if you want to switch controllers, start a new one, upload an old one because something's going weird, you have to make sure that you not only build it over here. So the build button will just compile basically your code and make sure everything's working okay. You want to build it and then make sure that the controller here is set. In this case, it's set. We're good. So just like with the robot class, whenever you use motors, and in this case the IMU, you also have to include the HPP or header files for that device. And then of course we have using namespace Weebots. So we go inside main, and so far everything is still the same. You always have to do robot, new robot, and you always have to get the time step from the environment itself so that you can actually make proper steps. Okay, now this is the actual process of, this is when the robot starts to actually interact with the environment itself. So before you saw that left wheel motor and right wheel motor were the two motors that come with the epoch. So there's the motor class, and star left motor equals robot get motor, and then you pass in the name of the motor. If you get this name wrong, the controller will just crash. It'll say it did not find what you were looking for. So you got to be extra careful that you get the name right. You can't really just guess. So once you get the motors, the way they normally work is when you first start, you can give it a position, how much you want it to rotate, and it'll rotate that set amount and then just stop. So if you've used encoders before, it's kind of like that. It can measure how far it rotates, and then it can stop on that position. However, we want to use it for regular continuous motors, turning, going back and forth, doing all kinds of things with the robot. So this next thing is to allow us to do that. So we set the position, not to any specific position, but rather to infinity, which basically unlocks the wheels to turn as much as we want. And then when you set it to infinity, actually, it starts moving forward. So the best thing to do right after setting it to infinity is to also set the velocity to 0 to ensure that it doesn't go anywhere. Because like I said, the way it normally works is like the velocity is already set, and you just tell it what position to go to, and it does it for you. But we're going to control the velocity rather than the position. So we set the position to infinity and the velocity to 0 so that our robot just kind of stays at rest there. So anyway, that's all you need for the motors. Those 6 lines would set your motors up for any program that you want to do with your motors. And now next we have the inertial unit. Now, I just want to say real quick that Weebots has a great reference manual here for all of its sensors, including motors and stuff. And you can see the different languages here, what the different languages implementation is. So for us, it's C++. By default, it's C. And unfortunately, everything down here in the description stays as C. But if you select C++ and you find the function you want, for us, it's get roll pitch yaw. There is a get roll pitch yaw. It's just in a slightly different format. But there is really good resources for this. Now, the first one we're going to need to do after creating it is we're going to need to enable it, which is basically just starting it up. So we first create it by, again, using a get function. It's not get motor this time, though. It's just get inertial unit, my IMU, and it's the same for all sensors. So if you have a LiDAR, it's just get get LiDAR, and then you pass in the name. And then this is how you enable it. Same thing with every sensor. You just pass the name, arrow, enable, and then you pass in the time step so that the sensor and the robot and the simulation are all working together at the same time step. And just like before, we have to be calling this inside a loop. Otherwise, the simulation will basically what happens is it looks like it hangs. It just kind of stops doing time here. It stops moving on the speed here. So like normally you want to see this at 1.00x. That means you're moving, like the simulation is operating at the same speed as real time if you're at 1.00x. If it for some reason drops all the way to 0, that means you're just simply not stepping. The simulation is just not running, even if you have the play button pressed, because you're never telling the simulation to continue. So this while loop really is where you want to put everything. So then, just like we set the velocity up here, we can set the velocity down here. I just set it to 1 and -1, which will just do a point turn. And then we get the yaw, pitch, and roll for the IMU. So just like we saw before, whoops, hold on. There's this function get yaw, pitch, and roll, and it describes it down here. So it returns 3 components, roll, pitch, and yaw in that order. And they have the indices, so it's an array. They have the indices 0, 1, and 2, and that is roll, pitch, and yaw. The roll, pitch, and yaw angles respectively. Well, we know in this case, well, I know in this case that all I want is the yaw. Yaw is basically like the left to right rotation, whereas roll is the robot rotating like on its wheels back and forth, and pitch is when it goes up and down hills. So we just want yaw. Which direction is it facing? So I do IMU, get roll, pitch, yaw, and I just automatically index it to get the second element, which again, sorry, acting weird, which again is the where is it? It's the yaw. So it's index 2 is the yaw. All right. And then it does return the value in radians. So I'm just doing a little calculation here to convert it from radians to degrees. So let me just show you what it's like when I build this. So it goes through this whole build. And if something's wrong, like I changed this name. Hold on, sorry. Uh-oh, it's taking a little while. Like if I got this name wrong, my IMU, it would give me issues. That's weird. It's supposed to say done. Well, if it fails at this part, that's all right because the EXE is already in there. So starting from a reset position here, if I press play, well, what it's going to do is it's going to go through all the setup and everything, and then it's going to start going through steps. And it's going to do it's going to set the left and right motor, and then it's going to get the yaw and print it. So here you can see it's starting to measure the degrees. 0 is, I believe, it's always like to the east. So the way it was facing from the beginning is always 0. And then as you start turning towards north, it goes towards positive 90. And then as you start turning all the way towards west, it reaches like positive 179.999. And then full due west is going to be 0. Or sorry. Well, it transitions from like the positives to the negatives as it starts to turn past that. So everything over here is negative. Everything over here is positive. So you can always get your current position and then calculate where you need to go and make whatever turn you need to. So here it goes. And it's about 90 now. And then I'll get closer to 180 and then make that transition. So you can use just regular old if statements, just like any with whatever programming language you're using, and you could use that to set it so that it only turns 90 degrees, something like that. Okay, so we covered all that. All right. So pretty sure I covered everything. Here's a sample controller, and we will supply these sample codes for you to take a look at. And so I'm going to open up another world right now. This one was just a basic one I wanted to show you guys to introduce you to Weebots. And you also make, when you go through the Weebots tutorials, you make something very similar to this. The Weebots tutorial actually takes you step by step of creating it and then going in and modifying the floor and the wall. So you can change the size, you can change the tile size to be, whatever you want. And that's what the tutorial is, but this was just a little bit of a quicker introduction. So let's see. Why don't I go ahead and open a new world just called line symbol. So in this example here, this is a slightly different robot. It's still two-wheel drive, but this one's just a little different. It's called the Pioneer 3DX. And you can see here, this one actually has a different sensor on it. This is a camera. And so the camera view, which you'll see here if I run it, the camera view, it's very pixelated and very blurry because we're not really using it as a full-blown camera. It's just basically to simulate a light sensor. So to simulate the light sensor, we just grab a pixel right here in the middle in this case. And you can see the camera's facing down because I am doing an optional rendering of the camera. And you can see here, just like the other one, it's right here inside a group, inside the subnodes for the Pioneer 3DX. And I just called it color sensor. So real quickly, just like the IMU, there is a header file you need to add for the camera. You also have to do a get camera, pass in the name that matches. And then you can get images from it and get gray values and things like that. And so what this one can do is it can line trace. And this world here is fully, modifiable through this scene tree. So if I want to change a tile, well, let me just run it first. So you can see here, I'm just displaying some values down here of the ratios between red and green because I'm trying to stop when it reaches red. And hopefully it'll do that. While this is running here, let me just show you. Once you create these base tiles, it's as easy as just copying and pasting a tile, moving it over. Why don't I just show you? So I just made another one here, solid 9, and I can slide it on over, line it up, whoops. Okay, and then if I want this to be something different, I just go into the scene tree. Now, this is a little bit long-winded, but once you do it once or twice, it's kind of easy to remember. So I'm trying to change basically the image here that's laying on top of the solid. In this case, it's it's a plane, right? So it's just a flat plane with a picture on it. And the pictures, by the way, come from this Weebots project directory. Is just right in here inside tiles. So that's what tiles is for. Again, that doesn't come with Weebots, but we'll post it up. So if I go in and I want to change the appearance, which is a little different than the one we did before, I can change the texture, URL, and now URL is basically just a file path. So this is a relative file path. And if I say select, I can go right in here and change it to whatever I want. So maybe I want this crazy turn here. And then there it goes. Now, this is a good example of what not to do. So while the simulation was running, I added something to the worlds. And so if I hit save now, it's going to warn me that the simulation is run, things have changed. Am I sure I want to do this? And typically you want to avoid it as much as possible. But if I was to reset the simulation, the frame disappears. So just be careful about that. You should always make sure everything is paused and reset back to the beginning before adding in a new element. And by the way, you might be noticing something over here that I haven't really talked about yet. This is just a way to do a delay function that's similar to like what we've used in Robot C and Arduino and things like that. Weebots doesn't come with it natively, so we had to, add it ourselves. But it works the same. The simulation will continue running. So when delay gets called, the simulation keeps going, but your code will just, wait for the delay to finish and then continue. I can give an example of that in here. So box controller. So box controller also has a delay because the goal of box controller is to basically drive around this big box. and you can set the speeds and then set a delay time. So the simulation keeps going, but the code won't, continue on until that delay is fully finished. So again, I mentioned this before, but here's an example. So I've got sample controller loaded on here just fine. Let me reset everything. So I've got sample controller loaded onto this robot right here in the controllers, but now I want to run box controller. And all of this is inside the tutorials as well. So I say select, and now I get my options here. So these are all of the, wait, hold on. What is, these are not all of the options. Hold on one second. That's fine, e-box. So pause it. Um, there we go. I don't know what was happening before, but here's all my controllers in here. And so I want to run this box controller over here, and all it does is drive around the box one full time and then stop. So if I go down and I find, where is it? It would be at the top, box controller. Okay. So now this is loaded up. Let me save just to make sure it stays there. Now, some other cool features that you have is you can change how the camera actually follows it. So we can do these cool renderings, and we can also follow the robot. So if I play it like this, it's kind of like the normal way you would observe a robot. It's going to go forward, turn, drive around. But if you want to like zoom in and see something more specific, I can change my view, say follow object tracking shot. Okay. And I'll move around with it. It'll just kind of, the camera will follow it. It won't deviate. And then I can also change that to something a little different. Mounted shot stays with it, and the camera stays at this position right here. So you'll always be viewing the left side like that, which I think kind of looks really cool. And then there's pan and tilt shot. Well, it ended, so I'm not. Okay, so I guess the camera just stays in one position and follows it with pan and tilt. So as if you were following it with your left mouse and right mouse clicks. Okay, so I have some other samples here that I can show you in the controllers. So there's IMU sample distance sensor. So again, just like every other sensor, it kind of works the same way. And so when you're working on a new sensor and you want to add something new to your robot that you haven't quite done before, just look back at your old code with the sensors you have, and then go to this very nice documentation. So if we want to do distance sensor, I can find distance sensor, and there's a lot of information here if you want to read through it. But just like with the IMU, there's a get distance sensor function, and then you have to enable it, same thing. And then you can see here what your different functions are for getting data from the sensor, for setting values to it. And that would be get value here. Get value function returns the last value measured from the specified distance sensor. So there's a lot here, but if you look for the specific stuff you want, then you can find it generally pretty easily in the description. Okay, so as you can see, that code in here does that same thing, distance sensor, enable. Oh, the other thing that's different here, I should have mentioned this. I have robot and time step. It's actually global now, whereas before in the first sample I showed you guys, it was local to main. The only reason I did this and made them global was because I need to use robot and time step both inside this function of mine. So they cannot be local because then the function wouldn't work. So I made those global, and then everything else though it goes generally the same. I set my left motor position and velocity, right motor position velocity, and then there's my while loop. So I can go ahead and run this code. Oops, I think my robot got stuck. It's all right. So select, and that's just called sample distance sensor. Oops, wrong one. And so as I'm showing this sample, I guess I'm going to open it up to any questions if anybody has any, specific or general, but I've selected the sample distance sensor. Let me save after having reset. And then if I play it, so what it does is it's just displaying them. And like, if it's the first time using a sensor, maybe all you want to do is see what the values are. How does it work? And so this distance sensor actually is set up a little bit weird. It uses, the onboard epoch one, and the onboard epoch distance sensor uses like some light reflectivity to tell if it's near things. So it's not a very good distance sensor in terms of sensing objects out in a field, but it's meant for if you're like driving like a Roomba, the robot that drives around the room cleaning surfaces. It can detect very well when it's in proximity to walls and it's in a corner. So it can prevent, the epoch can basically prevent itself from bumping into things. So as you can see here, the distance is just kind of floating around 60s and 70s. But as I get close to a wall, it'll pick up the light reflection and then it'll register, okay, there's something right in front of me. Time to turn around and go a different direction because I don't want to bump into the wall. So you can turn and then now there's nothing in front of you. And the way it works is it has these distance sensors. Hold on. This is a distance sensor right here. And then this is a distance sensor. So it's basically surrounded in distance sensors to be able to navigate through rooms and do complex stuff like SLAM. So yeah, that's the last sample I'll go over. Thank you very much, everybody, for coming. I hope you enjoyed this. And I just want to reiterate that this wasn't, a way to get you to start doing Weebots right away. This was just a little introduction to some of the terminology so that hopefully starting the tutorials can be a little bit easier. The tutorials kind of just really throw you right into with all the terminology, controllers, worlds, protos, all this stuff, and it's kind of a little confusing. So I thought this would be nice to see first. And there's one other, there's one other thing that is mentioned in the tutorials. It's called a supervisor. So there's a special trait that all robots can have set to true, and it's on here somewhere, but it's called supervisor, right? And so this one is set to false, but if your robot has supervisor set to true, then the robot actually has the capability of like moving objects on the field and measuring certain things, and like, operating on it as if it was a human, as if it was me. So like if you're doing hold on, let me stop this lock. None. So if you're doing something with let's say the rescue room in RCJ, it can randomize, like a supervisor robot can for you randomize the position of the victims, or if you're doing a simulation, you knock over an object that you don't want knocked over, a supervisor can like replace that object back to where it was. So that's another thing that the tutorials go into is, how to make a supervisor. And a supervisor is just a very powerful robot that can like do whatever it wants in the simulation. All right. So thank you very much for coming, and I hope you guys learned a little bit. And if you have any questions, feel free to ask.